Okay, now, looking at this Pascal's triangle, if you first look at it, it might be confusing, but it can be very helpful, okay? Now, if we look at this, okay, a binomial expansion, okay, that's when we are multiplying polynomials like a plus b squared, a plus b cubed, a plus b to the fifth power, you know, things like that. Binomial expansion, we can always multiply it out. We can use our FOIL method. There we go. A plus b times a plus b, and we can go first, outside, inside, last. Yes? We can do that. And then if we have another a plus b, if it's cubed, we can take that result and multiply it to a plus b. And then if it's to the fourth power, we would take that result and multiply it to a times b. So I mean, it just gets longer and longer and longer. Yes? Okay, well with the Pascal's triangle, it helps us. Now we all know that this would be a squared plus 2ab plus b squared. Yes? Right? Because a times a is a squared, a times b is ab. We multiplied a to everything. Now we have b times a, which is still ab. Yes? We have b times b, which is b squared, and we still get a squared plus 2ab plus b squared. Same thing, yes? And when it's just to the second power, it's kind of easy. But what Pascal's triangle does is it gives us our coefficient. Okay? So we have 1a squared, yes? Because this is to the 0 power, this is to the first power, this is to the second power, this is to the third power, yes? And if we look, first power, second power, third power, fourth power, fifth power, yes? Everybody see what I'm doing? Okay. So what Pascal's triangle tells us is these are our coefficients. Do you understand that? And you might say, okay, well, how do you make the triangle? Well, let's pay attention. We always put 1, 1, and 1. Everybody there? Now, all along the diagonals are 1, yes? What's 1 plus 1? What's 1 plus 2? 2 plus 1. Everybody see that? What's 1 plus 3? 3 plus 3 is? 3 plus 1 is? You see this? Okay, so if we're going to, I'm going to erase this, but if we're going to continue out our Pascal's triangle, and I'm going to do it in green, yes? 1 comes along on the outside, yes? And this is to the fifth power, right? This would be to the sixth power for 2 reasons. 1, 2, 3, 4, 5, 6, yes? And what's 1 plus 5? Now what number goes here? How? What else? 15. How'd you get that? 5 plus 10 is 15. What number goes here? Because 10 and 10 make, and 10 and 5 make. And so these are the coefficients when I'm going to the sixth power. And you might go, oh, okay, maybe I understand it, maybe I don't. But what that is if I have a plus b, and I'm expanding that to the sixth power. Yes? Okay. This would be a to the sixth, because that's my highest exponent, yes? And I'm going to have to give myself more room. I can already tell you that right now. A to the sixth, yeah? This, yes? Plus 6 times, yes? And what I have to do is my a exponent is going to go down. What's going to happen with my b exponent? It's going to go up. So this would be a to the what? And I'm not going to put it in parentheses. If the a exponent goes down, what is it? Y'all better talk louder.
6, 8 plus 4. Yeah.
I can't hear you.
A to the fifth.
To the fifth.
Okay. And b to the?
6.
7.
No. My b is going to go up. How many b's are here?
6.
Oh.
How many b's are right here?
0.
0. So how many b's are here?
1.
Do you see what we're doing? Plus, and then my next one would be 15, yes? Times a to the what?
To the fifth.
What happens to my A's?
Oh, to the fourth.
And then B,
B to the second.
because my B's are going to go up. Yes? Okay. Plus 20, because 20 is my next one. Yes? A to the what?
To the third.
B to the what?
To the third.
I'm going to have to write down here, even though we should write it sideways, okay? And then I've got 15A to the what?
Second.
B to the what?
Fourth.
Plus what?
Plus, plus A to the second.
So it'd just be A, B to the third, right?
Oh, just A, yeah.
A, B to the
Fifth.
fifth?
Yeah, third one.
Okay, we're missing. Okay, plus B to the sixth, yes. Is that right? I don't think so. This would be 6, 5, 4, 3, 2, 1. Did I miss one? 5 is 6, 15, 20, 15. I did. What's 5 plus 1?
6.
So I thought there was one. So our exponent here, this right here, should be 6, 15, 20, 15. Sorry, it doesn't look right. 6 and 1. Yes? Hello? So this right here, we have to correct. So we have the 15. This 15 is right here. So this would be 6. Yes?
A,
A.
B to the fifth.
And then what?
Then A, B to the sixth.
B to the sixth. A is 1, so it'd be A to the 0, which is 1 power, yes? Okay, so this is how we're going to utilize it. Everybody with me? You'll have to catch up for just a second, okay? All right, so what we're going to do is we're going to create our own for just a minute. Everybody with me? Okay, so, and actually, just because we're filming, I'm not going to take the time to create it right this minute. Is that okay with you guys? But we do understand that we have to know how to create them. Yes or no?
Yeah.
Okay. I'm going to copy this. I'm going to put it right here. I'm going to mask this for just a second because I only want the triangle. Is that okay with you guys?
Yeah.
Now, this triangle only goes down to the 5th power. Yes? That's this power right here that we're needing. Do you guys understand me? Okay, so it only goes to there. So if I'm going to expand this, now the truth is I can take, and I'm just going to write down here, I can take z plus 3 times z plus 3 times z plus 3 times z plus 3. I absolutely can. Do you understand that? Yes? But if I have what, I'm going to call it another cheat chart, yes? If I have a cheat chart, why not use that cheat chart? Yes? Okay. So instead of doing all that, I'm going to use Pascal's triangle. This line right here is to the 4th power. Agree or disagree?
Agree.
Okay, so I'm going to have 1, that's the coefficient, 1, yeah, 1, times my first term, z, yes? Yes? To the 4th power. Right or wrong? Because that's my highest exponent. To the 4th. Yes? Everybody following me?
Yes.
Okay. Plus, what's my next coefficient? 4. 4 times z, yes? To the 3rd power times 3 to, what power's on that 3? How many 3's are here? 0. So how many 3's are here?
1.
1. So how many 3's will be in the next one?
2.
Everybody understand that? Okay. So all I'm going to do is write this out and then I will simplify it. You guys with me?
Yes.
Okay. Plus, what's the next coefficient? 6 times z to the what? 2nd, because these exponents go down as the exponent on the 3's go up. Yes or no?
Yes.
3 to the what? How many 3's are here?
It will be the second.
Okay. What's my next coefficient? 4 times what? Z to the what? First, right? 3 to the what? Third. And I don't know why this doesn't work well. 3 to the third. Good Lord. I'm going to write this under here so we can see it better. Is that okay? Can't see it that much better. Goodness. 3 to the third. Okay. And then plus our last one, yes? It would actually be z to the 0 power, yes? But 0 power is 1. It is something that's 1. Okay. Plus 3 to the what power? 4th. Yes? So let's just step back and check. I have z to the 4th, z cubed, z squared, z to the 1st, z to the 0. I didn't miss any, did I? So now let's check our second term. No 3's here, 1 here, 2 here, 3 here, 4 there, yes? So now I need to start simplifying. Z to the 4th is z to the 4th, yes? What's 1 times z to the 4th? Yes? Okay. I have, what's z cubed? That's just z cubed, yes? And then I have 4 times 3, which is 12. So this would be plus 12z cubed, yes? 3 squared is? 9 times 6 is? So I've got positive 54, yes? Z squared, very good. Plus, okay, what's 3 cubed? 3 times 3 is? Times 3 is? 27. So I have 27 times 4. What's 27 times 4? 27 times 4?
108, right?
Yes. 108. What? Z, right? I don't have any? Yes? And then I have plus 3 to the 4th. What's 3 to the 4th power? Oh, wait. 3 times 3 is? Times 3 is? Times 3 is? What?
108.
Nope.
No, it's
81. So, this, we still have to do some math computations, yes? But it is quicker than taking z plus 3 times z plus 3 times z plus 3 times z plus 3. Agreed or not agreed? Okay? But again, we have to know how to read this, yes? Okay? Now the next one, 2t minus 1 to the 5th power. So we're going to use which line up here? Bottom one. Absolutely. We're going to use the bottom one. Can I erase this? Anybody need it? Okay. Erase that one. So I need it to the 5th power. So what is my first term in this? 2. It's a t.
Oh, sorry.
That's okay. So I have 2t, yes?
Yes.
To the what power? To the 5th power, yes? Okay, now we have to be careful because that's a minus sign, yes? Okay, I'm still going to put a plus. I may have to change that plus when I go to simplify it. Do we understand that? Okay, so now what coefficient do I use? Because this is my second term. What's coefficient? Second term.
5.
Thank you. So I use 5. So I have 5. 5 is my coefficient, yes? 5 times my first term to the 4th power, yes? Times my second term, which is a negative 1, to the 1st power, yes or no? I'm color coding. Everybody with me? Yes? Okay, plus, I've got 2t, what's the exponent on that 2t? Cubed, yes?
Yeah,
Oh, what did we forget though?
we forgot
The what? Nope. What did we forget? The 10. We don't want to go too much further. We have this 10. We've got to do the coefficient, yes? 10 is the coefficient. Now we do 2t to the what power? Third power times our -1 to what power? Second. Everybody with me? I'm running out of room. So I'm going to just write down here. Is that okay? Okay. So my next, what's my coefficient of my next term? 10. And then I write down what?
2t for second.
Fourth. Fourth? Okay, good. I heard somebody say fourth. But it is to the second power because these go down, yes? As these go up. Yes or no? Okay. So now we have -1 to the what power? Third power. Plus, what's our next coefficient? 5. Now what?
2t.
Nice and loud. What do I put?
Times 2t.
2t. Okay. Do I have an exponent?
No.
It's to the first power, so don't write that. Yes. And
Times
then what? -1 to the fourth power. Okay, are we done?
No.
Okay, what's our last one?
One.
Plus -1
Plus -1 to the fifth power. Everybody with me? Okay, now I need to go back and simplify it. And notice, and I want you to emphasize, that I kept the sign with the number. Do you understand me? Okay, so here I go. 2t to the fifth power. 2 to the fifth power is 32, yes?
Yep.
Okay, so I've got 32t to the fifth power. Everybody there?
Yes, ma'am.
Now, here's where you have to be careful. I have 2t to the fourth power. 2 to the fourth power is 16. Yes? So, I've got 5 times 16 times t to the fourth times a -1. 5 times 16 is 90, yes? But what's 90 times a -1? So -90t to the fourth power. Everybody see what I've done? I do not want plus a negative in your work at all. Do we understand that?
Yes, ma'am.
Okay. So our third term, yes? And it's real easy to look. -1 squared is going to be a +1, yes? So my next answer is going to be plus something. Everybody with me? Yes? Okay. What's 2 cubed? 2 cubed is 8, yes? So I have 8t squared times 10. That's 80t cubed, yes?
Yes.
8t cubed times 10 is 80t cubed. So far, so good? Okay, our next one. 2 squared is 4. 4 times 10 is 40, yes? But a -1 cubed is a -1, so I have a -40t squared. Yes? So far, so good? Okay. Our next one is 5 times 2t, which is 10t. This becomes a +1, so I got plus 10t. Are you there? Okay. And then I have a -1 to the fifth power is -1. Everybody with me? Questions? No? So, even though it's not quick, simple, and easy, it's still simpler than having to multiply that out 5 times. Would you not agree? Questions? Anybody? No? Okay. So I want to go back a couple. Right here. Now, we have done, I call this the difference of 2 squares, sum and difference, yes? When we have something, I don't know, give me a number, any number, somebody.
4.
Okay, I heard 6. Give me a variable.
A.
A. Okay. Plus, give me another number. Not an even.
24. 27.
Okay, I heard 5. Okay, and then 6a minus 5. This is a difference of 2 squares, yes? I can multiply this out. I can FOIL it out. Do you understand me? But I don't have to. Since this is the difference of 2 squares, my middle term will cancel each time, every time, all the time. Yes? My answer will be the first one squared, 36a squared, minus the second one squared, which is 25. if you're not sure, 6a times 6a is 36a squared, yes? 6a times a negative 5 is a negative 30a. That one. 5 times 6a is a positive 30a, yes? Negative 5 and positive 5 is a negative 25. These cancel. 36a squared minus 25. I saved myself a minute, maybe more. Do you understand that? We've done this, yes? Okay. Just like we've done our perfect squares. We could use my Pascal's triangle, yes? If we look back here on Pascal's triangle, perfect square 1, 2, 1, yes? But I told you it's the first one squared, the last one squared, yes? Plus 2 times my first term times my last term, yes? Yes? That gives me a squared plus 2ab plus b squared, yes? As with it be 1, 2, 1 on Pascal's triangle, yes? A squared plus 2 times the first term a times the second term b, yes? Because a's go down, b's go up, yeah? How's that different? It's not, is it? The key here, be sure if it's negative, keep the negative with, keep the sign with the number, all right? Questions? Anybody so far? Okay, now we've done a perfect square. We've done the difference of two squares. What is new is my cubes. And again, I can go back to my Pascal's triangle if I want. This is a pretty cubed, 1, 3, 3, 1, yes? Okay, so I'm going to come here, and I'm just going to write it here just for us if we want to use it in a minute. Is that okay with you? Or they tell us, yeah? I'm going to have, I don't want that one. I want this one, sorry. What's the coefficient here? 1. What's this?
3.
What's this?
3.
What's the coefficient here?
1.
How's that different? Is it? Okay. So either we remember a cube's 1, 3, 3, 1, or we draw our Pascal's triangle. Do we understand that? Okay. Let's just close this out for a minute, and we're just going to use this, all right? My first one, 1, it'd be z cubed, yes? Plus 3 coefficient times my first term, yes, squared, yeah, times my second term, which is 3 to the first power. Right or wrong?
Right.
Okay. 1, 3, 3. This is 3 to z, yes? This is 0, 3s, 1, 3, 2 3s, yeah? Plus 3 cubed. So far, so good? And if we look, my coefficient's 1, 3, 3, 1. Yes? Okay. So this is z cubed. 3 times 3 is 9. Yes? This is 9 times 3 is 27. Yes? And 3 cubed is 27. So far, so good? Are we right?
Are you supposed to put that to the second?
No, thank you. I tend to get a little happy sometimes when I'm going. But yeah, thank you. But no, I was not. So it's right. Questions? And when it's a negative, okay, you can remember your 1, 3, 3, 1s, and that would give you this would be negative and this would be negative because you've got to the first exponent and third. Those are odds. Everybody with me?
Yes.
Questions? Okay. Now, you might go, okay, why is she doing all this? Why is she telling us all this? Because when we get stuff like this, we should be able to kick it out. I mean, just boom. Do we understand? I'm going to swoop this down just a little bit so, I can reach it. So, shut up, Oscar. Okay, here we go. So, this right here, difference of two squares. We should kick it out right now. What's the answer? X second what?
Minus 81.
Okay. No problem, yeah? Okay, difference of two squares. So, what's this one? Let's go with Keaton.
You're talking about 38?
Yes, sir.
2y to the second power?
Okay, yes and no, but the 2 has to be squared too.
Right.
So, what's 2 squared?
4.
So, it'd be 4y to the second power. Yeah?
Right.
Alright, now what?
Well, that's 25.
Nope.
4 minus.
It'll be minus. What's a negative times a positive? Negative. So, in our difference of two squares, it will always, each time, every time, all the time, be minus. Do we understand? Always. Okay, questions so far? Alright. So, we have the difference of two squares. So, let's look at number 40. Number 40 is a perfect square, yes? So, it'd be 1, 2, 1 on Pascal's triangle, right? So, or we could say, okay, it's my first one squared. 9g squared is 81.
G.
I'm making up numbers, I don't know. 81, yeah, right back there, it's g squared. Okay, first one squared, yes? Now, our middle term is our first term, yes? Times the last term, yes?
Yes.
Times 2. 2 is standard. Do we understand that?
Yes.
9 times a negative 4 is negative 36. Negative 36 times 2 is what? Negative 72? And we have g. Yes or no?
Yes.
Negative 72g. Yeah? What's a negative 4 times a negative 4? Positive 16. Save the sign. And so now we're done. 1, 2, 1. Well, we didn't do 1, 2, 1. We did it like that. But if we did 1 times 9g squared, yes? Plus 2 times 9g times a negative 4, yes? Plus 1 times a negative 4 squared. Isn't that the same thing that we did? And this, my squared's in the wrong place. 9g squared. There we go. Yes? Same thing. Whether or not we use Pascal's triangle or we remember the shortcut. Do you understand me? So I don't have to go through all of these, do I? Okay, when we get down to like 46, 47, actually 45, any of these, we definitely want to use Pascal's triangle, right or wrong.
Right.
This one we can use Pascal's triangle, or remember it's 1, 3, 3, 1. Doesn't really matter, because you're still using Pascal's triangle whether or not you know it. Do we understand that? Questions? Okay, I have a question for you. Can you create a Pascal's triangle? Because you're going to have to. Do we understand that? Yes or no? You have any questions? Okay. All right, so your assignment is already on Google Classroom. You have 10 questions. Some are really easy, some will take you a little time. Not that they're hard. Do we understand that?
Yes, ma'am.
All right, these are due tomorrow as you come in.